We're going to cover 11.2 and 11.3 today. 11.2 is the areas of trapezoids, rhombuses, and kites. So some more area formulas. And 11.3 is perimeter and area of similar figures. So on the quizzes, you're going to have a quiz next time where we're 11.1 to 11.3. On the quiz, you will be given formulas. Okay, it won't tell you what the formulas are for. It'll just give you, the right side of a formula. So it'll be on the back of the quiz. So you'll have formulas to choose from to apply to specific problems, but you need to be familiar with what formula is used for what shape. I won't tell you area of a kite equals 1/2 d1 times d2. It'll just say 1/2 d1 to d2, and then it'll have base times height and that kind of thing. So there'll be a list of formulas without telling you what they're used for. You've got to know what to use them for. That's what you can expect on the quiz next time. Learning targets. You will also find areas of other types of quadrilaterals. Before we use ratios to find perimeters of similar figures. Today we will use ratios to find areas of similar figures. So the areas of trapezoids, rhombuses, and kites. Trapezoid. The height of a trapezoid is the perpendicular distance between its bases. Okay, so it's always the perpendicular line is your height. It's never this slanted side. That will never be your height. Area of a trapezoid. The area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. So that's written as area equals 1/2 base 1 plus base 2 times the height. Okay? 1/2 base 1 plus base 2 times the height. That's your area of a trapezoid. Any questions? All right, let's apply it. Let's do an example. So here we have a basketball lane. The free throw lane in a national basketball court is shaped like a trapezoid. Find the area of the free throw lane. All right, so we have our area formula, 1/2 base 1 base 2 times the height. So in this picture, base 1, if I can get it to right, what's going on here? There we go. We could call this base 1. We could call this base 2. It's not squared. Base 2, base 1, and then this would be the height. All right, so when we plug in, we're going to have 1/2. The height is 5.8. Base 1 is 3.6, and base 2 is 6. We multiply all that out. Okay. So we do the math, and let's see what we should get. What'd you guys get? Oh, there it is, 27.84. Should be your area. 27.84 meters squared. Now make sure you label the units meters squared. You get a half point on the tests and quizzes for giving the correct units, right? So you would write, I would write it, rather than write out meters squared, I would say 27.84 m squared, like that on my answer. All right, any questions? Okay. The height of a trapezoid is 5.8. The lengths of its bases are 3.6 and 6. Oh, this is a solution to the same problem. So we plug in and we get the 27.84. All right, two other shapes. We've got a rhombus here. The area of a rhombus is 1/2 the product of the lengths of its diagonals. So it's written as 1/2 d1 times d2. Now when you do the lengths of the diagonals, okay, make sure you're using the entire length across. It's not just half. That's not the diagonal. That's not the diagonal. It's all the way across. Why I caution you on that is because a lot of times they'll just give you like from this length from here to here. They'll say that's 5, right? But you have to multiply d1 as 10. What do we know? Why in a rhombus would they just give you that 5? What do we know about this? If this is 5, what's this? 5, right, because the diagonals bisect each other. So that's why they're just creating an extra step. That's 5, this is 5, so D2 would be 10. So make sure you're using the line all the way across for your diagonal. That's area of a rhombus. And then we've got area of a kite. And it's the same thing. 1/2 the product of the diagonals. D1 times D2. Another thing they will do with these diagonals is they will give you, they may say like that this is 3 and this hypotenuse is, we'd say that's 5, right? And this is a right triangle. To figure out diagonal 1 across here, I would have to do the Pythagorean theorem, right? Have to do the Pythagorean theorem and figure out, oh, okay, this is going to be 4. And then we'd have to do the same thing on the other side. They'd give you a length here. And you'd have to figure out this length and then add those two together. So there may be some extra work in finding the length of the diagonal. Here's an example. Music. The rhombus represents one of the inlays of a guitar. Find the area of the inlay. Okay? So we would use our formula, 1/2 area equals 1/2 D1 times D2. Alright, so this is doing what I was telling you, okay? Let's go back and look at the picture. This 9, they should more clearly mark what 9 would be. Because is it this whole line or is it this? We're going to say it's this half, okay? If that's 9, then we know that this length is 18. And we've got 12. We know that this length is 24. Right? PR is 24. So we find the area. Area is going to be 1/2 D1 times D2. So that's going to equal 1/2 18 times 24. Right? So, Gunnar, what is that? 1/2 18 times 24. 216. 216 millimeters squared. Questions? All right. So it's doing the same work we just did. (216 millimeters squared). So make sure you're labeling this millimeters squared. Any questions? Okay. Find the area of a kite. One diagonal of a kite is 2 times as long as the other diagonal. The area of the kite is 56.25 square inches. What are the lengths of the diagonals? How could we approach this? We have the area. We've got to find the diagonals. One diagonal is 2 times as long as the other. So what should we call the short diagonal? X. The short diagonal, this is X. Right, that's X. And then the long diagonal is what? 2X. So then we're going to plug that into 1/2 D1 times D2. So that area, we'd have 56.25 is equal to 1/2 X times 2X. Right? So we simplify that. That's going to be 56.25 is equal to the 1/2 and the 2 cancel. And we get X squared. So then we do the square root of 56.25 is what? What's the square root of 56.25? 7.5. So X is 7.5. And that would just be inches, not squared, because it's the length. And what would the other diagonal be? 15. 7.5 times 2. 15 inches. All right, any questions there?
Is it not inches squared?
No, it's not inches squared because it's the length of the diagonal. Right? We went from inches squared. This was inches squared. Now we just have the lengths just inches. All right. Go ahead, find the, okay, this is not on the notes. Okay? So let's work through this together. What formula do I use to find the area of a trapezoid? What's that formula? Gage?
That's 6 times 8.
No, just in the variables. What would it be? What's the general formula?
Base 1 plus base 2 times height.
Right. Base 1 plus base 2 times the height. Remember, when I grade these, you get a point for writing the general formula without even plugging in the numbers, just knowing the correct formula. That's a point. Okay, then we plug in. What do we plug in, Gage?
6 plus 8 times 4.
Yeah. 1/2, 6 plus 8 times that quantity times 4. Right? So that would be 2 times 14 is 28. And my units would be feet squared. Questions? All right. What formula did I use here, Jacob?
Area equals 1/2 D1 times D2.
Yeah, D1 times D2. So that's going to be 1/2. What do I plug in for D1? 14. D2? 6. So we've got 7 times 6. That's 42 inches squared. Okay, one more example here. We've got a rhombus. All right, so this is like I was telling you here. Well, what's the formula? What formula would I use there, Seth? Yeah, D1 times D2, okay. And then So we don't have the entire diagonal. We have the, let's kind of redraw this. We've got this little triangle here. We've got this much, and it tells it that this is 40 and this is 30, right? But we don't need to know the side length. I guess you don't need to redraw the triangle. All you need to do, what is, let's call this D1. What would D1 be, Seth? Yeah, we double it, 80. Okay, so it equals to 1/2 of 80 times what's D2? 60. 80 times 60. Okay, so that's going to be 40 times 60. Should be 2,400 meters squared. Right, there's our answer. Okay. (11.3). So 11.3, it's perimeter and area of similar figures. All right. So these two polygons are similar. Sides. So if the polygons are similar with the ratio, the lengths of corresponding sides have a ratio of A to B, then the ratio of the areas, we just would square A and B, right? Area is a squared unit, right? So if we know that the sides have a length A to B, then the areas are going to have the ratio of A squared to B squared. So we can go from side length to area without knowing all the dimensions to find the area. So so here we have the side. If the side of one polygon 1 is A and this polygon 2 is B, we can say their ratio is A to B. Then we know the ratio of the areas is A squared to B squared. So now we'll talk about how we apply this. So here's a breakdown. The sides have a ratio of A to B. If the sides have a ratio of A to B, what will the perimeters have a ratio of? They're similar. Perimeters are going to have the same ratio as the side length, A to B. Perimeters A to B. Their areas will have a ratio of A squared to B squared. And their volumes is going to be A cubed to B cubed. But I don't think we get into that in this section. But volumes would just be cubed. So here's how we apply this, what this does for us here. In the diagram, the two triangles are similar. The triangles have to be similar to compare these ratios. Okay? BC corresponds with EF. All right? So they want us to find the indicated ratio, the ratio of red to blue perimeters. What would the ratio of the perimeters be? Taylor? Faith? Ratio of the perimeters? It's the same as the ratio of the sides.
8/12.
8/12, right. And we'd reduce that. So the ratio of the perimeters would be, it's 8/12, red to blue. Put the one they named first on top, 8/12, which is equal to 2/3. So the ratio of the perimeters is 2:3. All right? Then it wants us to find the ratio of the areas. Ratio of the perimeters we said was 2:3. What's the ratio of the areas? Eric, ratio of areas is going to be what?
4 to 9.
Yeah, he squared them. It's going to be 2 squared over 3 squared, which is 4/9. Right? Okay, so here's the work on that. We've got that, okay. So now here's an application. We have a rectangular cooking pan that is 15 by 10. Let's draw a picture. 15 by 10. And the smaller pan, this is the large one, right? The smaller pan is similar to the large pan. The area of the smaller pan, so we draw our smaller pan, its area is 96 inches squared. Find the width, okay, which is x. Find the width of the smaller pan. All right. So, here's how we would do this. We have to find the area of the large pan. What's the area of the large pan? 150. 150. All right. So now we know the ratio of the areas. It's 150 over 96. Right? We have to find the width of the smaller pan. We've got to find x. So this is the area ratio, but to find x, we need to know the side ratio, right? So what could I do to the 150 over 96 to find the side ratio? If it's a squared, this is a squared to b squared. What would a to b be? A to b equals what? What would I do?
The square root of 150.
Yeah, exactly. We take the square root of 150 over 96. So do that for me. Gunnar, what's the square root of 150?
12.25.
12.25. And what's the square root of 96?
9.8.
11.8.
No, 9.8.
9.8?
Yeah.
All right. So now I know the ratio of the side lengths. The ratio of the side lengths is 12.5 to 9.8. So I'm going to say 12.525 is to 9.8, as we know the width of the big one, okay, it's on top, it's 10, is to x. See how I got that? I got the 10 from here. So this is the ratio of the side lengths. So I take a known side length, 10, I put it here. This is the unknown, that's x. Then we cross multiply and solve. All right, so that's going to be 12.25 x equals 98. Divide by 12.25. How many times does 12.25 go into 98? 8? 8? X equals 8. So the smaller width is 8. All right, so it's kind of complex, but everybody see how it works. You use the ratios. You got to convert them to the unit you have to find. We knew the ratio of the areas. We converted that, a squared b squared, to a over b, and then we use that ratio a over b to find the side, the width. Any questions? Okay. So they drew the diagram. Then they do the ratios, find the square root. Okay, it probably would have been better to go ahead and reduce these. You could have reduced those. What's going into both of them? 6 went into both of them, so it's a ratio of 4 to 5. But what we did was fine. And then they didn't cross multiply. I prefer that you use 4 over 5, and yeah. All right, so that's, let's look at another one. Example 2, standardized practice here. You're installing carpet, the same carpet in the room and den. The floors of the room are similar. Okay, they're similar, so that means they have the same, the sides are proportional. The carpet for the bedroom costs $225. It is sold by the square foot. How much does it cost to carpet the den? All right. So we know the ratio of the sides. The ratio of the sides is 10 to 14, right? Okay, what's the first thing we should do? I didn't do it last time. I should have done it. Simplify, right. So what's that simplify to? 5 over 7. So my ratio of my sides is 5 over 7. Now, we don't have an area in either one of these, but we have a cost that's based off of area, right? So can't we just use this cost sort of as our area? Right? It's going to be the same thing. It's just the area times a certain price. So the cost should be proportional to the ratio of the areas. So before I use this cost, what do I have to do to my side ratios? What do we have to do here? Since the cost is kind of like an area, what do I need to do to 5 over 7? This is the gist of this section. We have the ratio of sides. We need to know the ratio of areas. What do I do? Kennedy?
Raise the power to.
Yeah, we square them. So we have the ratio, this is sides, right here, right? We need areas. The areas are going to be 5 squared over 7 squared, which is equal to 25 over 49. Right? It's 25 to 49 is the ratio of the areas. So then I can take, let me clear this out, I need some room to write. So we would take 25 over 49, and we would set that equal to, okay, the bedroom is a smaller one, right? So that would be on top. We'd say 225 over x. Cross multiply, solve. So 25x equals to 225 times 49. Right? And we would multiply that out and solve. So what do you get for the cost of the carpet for the den? It should be less. That's one way. No, it should be more. Wait, did I do that right then? 225. Yeah, the bedroom is smaller. Yeah, so yeah, it should be more. What do you get for the cost of the den? 441? Sounds right. X equals 441, and we're going to label it with dollars. All right, everybody get the idea. So you're going between side length and area by squaring or taking the square root. Here's the work. Okay, so we've got, okay, here's a guided practice. The perimeter of a triangle ABC is 16. Its area is 64. The perimeter of DEF is 12. The two shapes are similar. Find the area of DEF. All right. Perimeter ratio. Perimeter is a length, right? It's all the sides added together. So it's treated like side length, okay? It's the length. So somebody tell me how we would set this up. What will we do in this problem? Jacob, what would you do?
You do 16 over 12,
Okay, we take 16 over 12.
and do 4 over 3.
Right, we reduce it. It's 4 over 3. Okay, then what do you do, Jacob?
You do the area
Okay, you're right. We've got area 64, but what do I have to do something before I use the 64. What do I have to do? Get Faith? We square it. Good. So it's going to be 4 squared over 3 squared equals 16 over 9. Okay. Then we take 16 over 9 and we set that equal to, let's see, which was on top? ABC was on top. This is ABC. This is DEF. Right? So we take the perimeter of DEF, then we have the area of ABC, 64. So what's my ratio look like? 16 over 9 equals what?
64 over X.
Yeah, 64 over X. Cross multiply. Well, let's reduce first. The 16 goes into 64 4 times. So that's 1, that's 4. Now we can cross multiply. X equals 36, and that would be feet squared, right? 36 feet squared. Any questions? All right. All right, are there more examples in your notes?
Yeah.
All right. Go ahead and work on those. Go ahead and work on those examples.